Hi Elliot, it's Tyler Muffley. Hope you're doing great. I just wanted to create a short video here that describes kind of the basis for what I did and how I did it to give some context. So I've been working on this project for many years now, a lot longer than I'd like to admit. But overall, our goal is to construct and validate a model to predict a medical student's chances of matching into an OBGYN residency. And I created a code book. I removed this race variable because race has become a real hot topic in terms of predictive models in OBGYN and elsewhere. So what I ended up was creating a clean PHI friendly data set with a unique identifier that I sent to you. And the data is a list of applicants from multiple sites. There were University of Colorado, Baylor Scott and White, University of Washington, total of 8, and then we compared that to people who were to residency, OBGYN residency web pages to see if they matched or not. And so what I've been working on is this file 000-1-G clean data feature engineering, which is running right now and should be done relatively soon here. So this is our code, and unfortunately I don't know how to code in Python, but this is the little bit of R that I know. So I have some custom functions here that load up the matching data and treat it similarly for every site. So what it does is it takes the location, so like University of Utah, and the year of the data, and cleans that and then loads it in as well and does some cleaning as well. So each of these steps is ingesting one of the years of data from University of Utah. The 2020 data in particular is differently formatted, and so I had to create a different function to read in the 2020 data. Unfortunately, I had to repeat myself a lot here, and would ideally love to create like a loop or something like that to do this, but I am just going for to get this done at this point. So we read in the data for Utah for every year. We bind those rows together, forcing the data types to all be the same, confirm the number of columns, the number of rows, and then write a file to our data folder called Utah Applicants Combined for Years. We do that for University of Colorado, Duke, University of Washington, University of Alabama, Baylor Scott and White in Temple, Texas, Cleveland Clinic, Akron General, Truman Medical Center, where I went to residency, in Kansas City, Missouri, and then bind all those sites together so we have all the applicants from all those years, and then write that to file. So this creates just a table of the number of applicants by institution. Data cleaning, this is another bespoke function that allows us to just clean the data so it all looks similar no matter the site. And feature engineering, so this is really where we're starting to get our data together. So our first data set is really this A_cleaned and quality check data. Of course, I'll have to fix that here. And let's do this. Okay. And So what were, so let's take a look at some of this stuff here. Okay. Oh, it's deleted. It's deleted this as it goes. Some of these as it goes because the data is getting too large in RAM. So what I do then is create this A1 steak sauce. Kind of a dumb name, but something that my dad always loved to eat. And looking, again, I commented out the self-identity or race variable. Hobbies for sports team and leadership. So in the AAMC application, there are these discrete fields that we can get. College degree, Ivy League college, did they attend undergrad at any of these Ivy Leagues? Are they a student member of the American Medical Association? Do they mention being in the OBGYN interest group? Are they a student member of the American College of Obstetricians and Gynecologists? Are they applying to a categorical versus a preliminary application? So University of Colorado has a prelim position where they take basically an extra resident, and that resident is guaranteed a 1-year position, not the 4-year position, and then usually goes on to find a job else, to find an open position elsewhere after that first year. And so the vast majority of people are applying to categorical positions, but if people don't match, then they usually apply to the preliminary position. Okay. Do they speak a foreign language? Do they have U.S. citizenship? Did they previously do residency? Did they graduate cum laude or summa cum laude? Did they get scholarships? Did they get grants? Were they in Phi Beta Kappa? Were they an NCAA athlete? Were they a Girl Scout or Boy Scout? Were they a valedictorian? Did they receive NIH training? Were they at a National Cancer Institute? Where were they born? Inside the U.S. or outside the U.S.? Did they go to a top-funded NIH medical school? Did they present at a meeting? Okay, so here, identify if the letter writer was an OBGYN or not. So we didn't identify if they were an OBGYN or not by their name, like Tyler Muffley is an OBGYN, but more by kind of what they described themselves as, their title, and if they had any of these strings in their title, they were considered an OBGYN. I need to do a little more work there to get it to be better. Okay, this is some data, some counts of professional experiences. This was a medical student, the first author. Here we go. That's the problem there. Thanks. Did they get a recommendation from the department chair, from the program director, from both? This was the gender of the letter writer. I got criticized by one of my mentors saying that shouldn't matter and I shouldn't even look at it because it's not statistically significant, or it's not biologically plausible that it would be a thing. I guess I disagree, but I don't want this to be a doom and gloom article. We create another model called Bertha with the A1 steak sauce plus the engineered results, doing some more cleaning on it, figuring out who matched and who didn't by bringing in a list of all OBGYNs, removing those people who are not residents and who are in Canada, and then matching by name, city, state, and finally selecting these variables. I did now include the step 2 result, giving your input. Thank you for that. And finally, reading it out. And that's probably enough for that. Thanks. More to come.